Hello, ninth grade. This video is to recap what we will be learning on Friday. So this video is going to use 6th hours handspan data that we collected a couple weeks ago. So first, I'm going to get the data in my notebook. So today is the 28th, but I'm going to title this the 30th because this is when you'll reference it. And this again is 6th hour handspan data. Feel free to fast forward or skip any parts of this video that you feel confident with. And I don't want to apologize for it being long, but it will take some time to get through all of these parts. So feel free to fast forward and pause where you would like to. So I am going to record the data. And I'm going to use the 3 columns that I have on the screen. So first, we're going to find the 5-number summary. And we can do that manually by looking at the minimum, the maximum, find the middle of our data, and then the middle of each half of our data. And so we can see that here is our minimum, our maximum, and knowing that our data, we had 24 students contribute to this data. And the middle would be the 12.5 data. So in between the 12th and the 13th piece of data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where our median will fall. And so first we have 13.5. And then we'll have a first quartile, and then our median, which is directly in the middle, and then our third quartile, and then our final maximum. So now thinking about this line, going halfway in between the data on before the median. So there's 12 pieces of data, so we need to go between the 6th and the 7th piece of data. 1, 2, 3, 4, 5, 6. And notice 1, 2, 3, 4, 5, 6. Directly in the middle, this is our Q1, the first quartile. Doing the same thing, but now to the right. 1, 2, 3, 4, 5, 6. And so our third quartile is 22. Halfway between 22 and 22. Now we're going to create a box plot and look at how our data is spread out. So I am going to go up in my notebook and create a number line that will represent these 5 numbers. And our box plot will be the handspan in centimeters. So I'm going to start at 13, and then going up by 2s. trying to go equal distant. So going up by 2s all the way to 25. And then I'm going to plot the data. 13.5, just a little past 13. Then here's the first quartile. Here's our median, our third quartile, and then our maximum is almost 25, 24.5. 24 would be about right here, so in between there. And then the whiskers, and then here is the box. And so there is our box plot. Now to analyze this box plot, let's look at some information regarding box plots. There's 25% of our data in each of these 4 sections. So we can see that 50% of our data fall between 17 and 22 centimeters. And if we go and look at our data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If we go up to, including 22, 15 of the 24. So just over half are actually in that range. But generally, there's 25% here, 25% here, 25% of our data here, and then the last 25% between the maximum or the extreme and the third quartile. So we could say 50% of students are below 20 centimeters or equal. We could also say that 50% of the students in 6th hour are between 17 and 22 centimeters. That is another interpretation. Now let's also look at its skewness. If this line in our box is directly in the middle, then we know we would have a symmetrical box plot. There wouldn't be a skew. Where the median is directly in the middle, it's the same distance to the quartiles and the minimum and the maximum. But notice that the median is just slightly closer to the right. It's just a little bit closer over here. So we could say this is slightly skewed right or skewed positive. Now, additional measures. Let's also look at, there it is. Let's look at the mean, the median, again, and the mode. So the mean of our data is 19.78. Remember that symbol, X bar, or X with a line over it? 19.78 centimeters. And notice that the median is 20 centimeters. And notice that the mode is also 20 centimeters. There are 5 students that had 20 centimeters for a hand span. Another important number to notice is the standard deviation. It is rounded to 2.98, which is very close to 3 centimeters. So on average, each student is about 3 centimeters from this 19.78 average. About 3 centimeters. Clearly, this maximum student is larger than 3 centimeters from the mean. And our minimum, that was 13.5, that's over 6 centimeters below the mean. So on average, each student is about 3 centimeters from the mean. Okay, I am going to go to a new page to talk about how we can use these two measures. And also, because the mean, the median, and the mode are all about 20, this tells us that our data is distributed normally. So now we're going to focus on the normal curve. And the information that we will need is the mean and the standard deviation. So let's record that again. 19.78 with our standard deviation about 3 centimeters. So what I would encourage you to do is to leave some space and then draw your number line. And this again represents the hand span in centimeters. And this is 6th hour data. Now I left 3 spaces. You might want 4 or 5 or maybe even 6. I've done this before, so I feel confident in how I can put the information here. But to give you a better visual for your notebook, you might increase those spaces. I always start at the center. And this measure of center will be where we begin, 19.78. But then we're going to increase it by 3 centimeters to the right and reduce it by 3 centimeters to the left. So adding 3 moving forward, we have 22.78, 25.78, 28.78. And then subtracting 3, 16.78, 13.78, and 10.78. Now remember that the normal curve, I always start from the middle, just like I started from the center on the number line, but it flows to the left and the right. And then there are certain percentages of our data that fall to the right and the left. So to remind you of how those percentages break down, here's that normal curve. So right here we have 34% right next to the mean And then going 2 standard deviations away, we have 13.5% here, 13.5% over here. And then it gets even smaller, 2.35%, and then just a very small amount, 0.15%. Finishing that on the other side, 0.15%. But now let's compare our actual data to these percentages. So if we were truly normal, if our handspans in class were truly on this normal curve, that means that 68% of students are between 16.78 and 22.78. But let's look at what actually is going on. Actually, what's going on here? So I'm going to go back to that data so that we can look at those numbers. Now, how many students have a score or have a handspan of 16.78 to 22.78? So I'm going to get my highlighter and I'm going to use green to highlight those that are between 16.78 all the way up to 22.78. So really between 16 and 23, not including 16 and 23. If we look at our raw data. And so we have 4, 6, 8, 10, 12. We have 15 students out of 24 students that are in this range. And when we look at that percentage, 15 divided 24, we get 0.625. So in all actuality, 62.5% of our students fall in that range. So we're not completely normal, but very close, very close. Let's also compare what about 2 standard deviations from the mean. So that means 95% of the students would fall between 13.78 and 25.78. So now I'm going to use a brighter color to indicate the students that are in this range. Let's use purple. It's a good contrast. So 13.78. So 13.5 is not in the data or in this range. And then all the way up to 25.78, which will include all the rest of our data. So that means 23 out of 24 students are in this range. Let's look at that percentage. 23 divided by 24, 95.8. So in this range, we are very normal according to the spread. We're only 0.8 of a percent away from what we'd expect. Thank you for watching this video.